The biggest revolution in 3D printing is yet to come. Alysia Garmulewicz thinks that 3D printing unlocks a new paradigm in design that allows us not only to replicate how nature designs structures, but also to mimic what nature uses to build objects. Alysia is an associate professor of high-tech entrepreneurship at the University de Santiago in Chile. She researches digital fabrication and the circular economy with a focus on open data and a local materials market for 3D printing. Welcome to the studio.
Thank you very much for having me.
So, if you say 3D printing, a lot of people think about these automakers, but you talk about using local, abundant, and often natural materials. So how is this different from like the basic understanding that people have about 3D printing?
Yeah, that's a good question. I mean, the two aspects to 3D printing, which I think is really important to understand from a sort of machine perspective, is that one, there are current machines that are really accessible, like you said, Ultimaker, that can be actually adapted to be fit for purpose for materials experimentation, and people are doing this in really interesting ways. So hacking the Ultimaker to extrude different types of pastes or ceramics or gels, etc., which opens the materials palette a lot to your own creativity, basically. So that's already happening and already possible, principally because Ultimaker and others like it are open source, so you can actually change the code in terms of being able to control the temperature for extrusion, all these sort of things, the nozzle size, a lot of flexibility. So that is one aspect. The other aspect where materials experimentation is happening at 3D is getting under the cover or under the hood of what 3D really is, and what it is a logic of fabrication. It's a logic of manufacturing, and the logic is adding material rather than a subtractive way that we currently cut away material to create an object. We can actually add material sequentially in order to build up an object. When you think of 3D printing as that logic writ large, the flexibility you have in terms of designing machines is huge. And so you see freeform 3D printer, I'm going to show you some on the slides today, that are basically a large robotic arm with an extrusion system that's linked onto it. And you can do a lot of things with respect to the extrusion system as well as just the freeform nature of the fabrication process. So that's what I want to uncover a little bit, is thinking about 3D printing as a logic of fabrication, and when it meets the material world, it becomes incredibly exciting. And what I'm going to put forward today is the idea that we are rapidly moving towards a world where more people in more places have the tools and the knowledge to fabricate things. And the key missing part of that, I believe, for that world of fabrication, which is rapidly moving in an accelerating direction, is what material palette we use. And so this talk is all about reinvigorating and tapping into the materials we have around us that are abundant, and thinking about how digital fabrication can make use of these ingredients to build fantastic things, and how pretty much anyone on the planet now is going to be able to have these tools at their fingertips, and what that means for the future of fabrication and the future of manufacturing and the future of the circular economy is incredibly exciting. So, to begin with, the main thesis of the talk is the future is already here. It's just not widely or evenly distributed, as Gibson has been attributed to saying. And there are three key parts to 3D printing meeting the circular economy. The first one is abundance in terms of materials, so the material palette. And luckily enough, we live in an incredibly abundant world when it comes to the biosphere and the materials that we have all around us, because other organisms produce and consume and cycle resources all around us. So plugging into that is really plugging into a world of abundance already. The second part is form, and this is where 3D printing as a technology, as a logic of fabrication, comes into its own. And the third key is intelligence. And what I'm going to show you today is the first two are already here. They're just maybe not evenly distributed. But the third is the intelligence. It's the understanding of what materials and how they behave, and putting that piece in. And that's where Materium, the organization and the platform that we're starting up, comes into play, is creating that infrastructure, that intelligence that undergirds this whole transformation. So this is a 3D printer. Leia is an incredible designer and innovator at the MIT Media Lab, and now she's at Tufts. And she did, for her thesis, 3D printing with chitosan. So chitosan, if you go back, is the building block of a lot of exoskeletons for insects, as well as I said, like shrimp and the shells of crabs, etc. And you can make, from chitin, you can make chitosan, which is deacetylated and basically can be printed. And here you have various viscosities. So with one recipe, one set of ingredients, I should say, you can make multiple recipes, right? And so as you can see, the varying colors show more or less viscous and more or less dense in terms of chitin or chitosan concentration. And that means that you can make all sorts of different plastics. So here's a sample again from her work where you can see when you print a chitosan plastic in, say, a honeycomb form or various structures. Again, imagine being informed by like the structure of bone or a wing, etc. You can make amazing forms that actually have varying performance. So for example, like a bag or actually freestanding structures they've also made incredibly strong as well. So use form and then vary the materials palette.
And where do you get the chitosan from? Yeah,
so chitosan is, as I said, it's from the polymer chitin, and chitin can be harvested from the shells of shrimp, of crabs, etc. And to give you an example of this as a design context, is that there is incredible amount of waste that comes from like fishing industries and food industries when it comes to seafood. And we don't currently see the shells of crabs, for example, as a very useful material from the perspective of what it goes into. It's usually just waste, like truly. And so what we're looking at is the idea of, you can actually derive chitosan from chitin and print plastics with it and make plastics with it. So often, so that's one major source that's just all around us and is often wasted.
Do you think that if you use this for example, packaging, that it has these ethical discussions around it because it's not a vegan packaging then?
Right. Well, the key thing is that, of course, like ethics and ethical choices are going to come into everything, and so it should. My approach to these kind of recipes is the idea of what makes sense in a particular locality. So what I think is the wrong approach is to say, what are we going to use as the alternative, and then scale it up massively and use an extractive mindset to then harvest, for example, from in an unsustainable way, fisheries and etc. in order to like have that resource be scaled massively for plastic packaging, for example. But if you think of it within a different paradigm of fabrication, a different paradigm of manufacturing where it's local, it's contextual, it's for markets that are in proportion to the feedstock available, then you have a choice set that's much more about how you as a human population within a specific locality can draw from and feed back nutrients to the ecosystem you're surrounded by. So that's where the choice set has to be contextual every time. And although we have the capacity worldwide now to fabricate amazing things, the actual nutrients and where they're coming from is incredibly centralized. We're basically grafting this networked fabrication revolution onto the supply chains of the 20th century. And that's just not good enough. It's not good enough for a world of abundance that the circular economy promises. And so this has led to the work basically in creating a distributed intelligence. And to do that, we're creating a recipe library of amazing recipes that use this palette, that use this abundant nutrient palette, including waste. So here, for example, and I've put up the examples of what designers are doing with this as an example of the recipes themselves. So number 7 is an incredible algae-based water bottle, or a bottle that has its integrity when it's filled up with water, which is really interesting. And one of the aspects I want to touch on there is the fact that nature uses water as a building block, and it's really a new kind of way and paradigm of understanding materials and how to use them is the more variable, the more contextualized way of fabricating, rather than standardizing a certain plastic and making and hoping that it's, or not hoping, but actually designing it to be highly stable throughout a linear production process. Is the way in which we currently hit on polymers and want to develop polymers that are very stable and can be manipulated and controlled, and then linearized in the supply chain. Whereas polymers like this are very contextual. They vary depending on humidity in the room, how you're going to actually fabricate the process itself. And that's why digital fabrication methods, which are inherently more place-based, as well as having, you know, the design freedom to do one-off or customized objects, that's where this comes into play. I guess just the thing I wanted to conclude with in that sense is the main questions that I really think should be guiding the evolution of the circular economy in terms of, you know, the way in which we chart the future of design and fabrication, is the ideas of how we choose the material palette, on what basis. I think needs to be infused with an idea of what makes sense from a systems perspective, informed by the way in which natural systems operate already. And when you look at that material palette, we have so much abundance around us, and we also have a lot of work to do collectively to think about how we can use these materials for the various functionality and products that we have. So it's an invitation to designers to link up with material developers, to link up with makers, to link up with small firms that are putting out new recipes. And I think that synthesis, as well as creating the strength of the data as a language that we can talk to one another, is a very exciting conversation. So for anyone who's in any space that touches this world, we have so much to do to basically invent a future where pretty much anyone, anywhere can fabricate amazing things with the abundant materials that are around us now.
Thank you so much. Thank you for being here.